So I'll just... Do you have that question about the rocket? Yeah? Good.
Still last question.
That was the last one. That's it. Right, let's have a look at this. You have a small rocket. These are those Chinese sweets, are they? No, alright. You have a small rocket. Here it is here. And I tell you that its mass is 100 kilograms. Yeah, what's wrong, Cora?
No, it's just for bench, yeah.
Are you happy? Are you okay?
Yep.
In the question, I say 90% is fuel. So what I mean by that is 90%, 90 kilograms is fuel, and then it's like 10 kilograms is actual rocket metal. Okay. Right, so my first question is, what is the weight? Well, that's no problem. Weight equals mg, which will be 100 times 9.81, which will be 981 newtons. So, my goodness, I hope that's okay, because if that's not okay, there's big problems. Okay, weight equals mg. Yeah? Right, now the next question is, what is the reaction force? Now, it's very important. In the question I said, when t is less than 0, and in the question I tell you the rocket moves, the engine turns on when t equals 0. Okay, so this means that the rocket has not started yet. It's still on the ground. So when that's the case, what can we say about the reaction force? It should equal what? If it's not moving. Yeah, the or equals... Yeah, which is W. No, oh, come on, guys. No, this is not going to work. This is not going to work. Are we listening? Are we listening? Are we awake? Yes? You see, I can see your eyes are open, but I'm not sure that you're awake. Okay? So let's have some interaction here, okay? So if it's not moving, what can I say about the reaction force that's going up?
0.
No? Not this?
It's the same as the weight.
Thank you, Grace. It's the same as the weight. And what does the weight equal? Yeah, and what is mg here? 981 newtons. So we have the reaction force is 981 newtons. Okay? Right. Now the next step is, what is the thrust? Now, you maybe have to use your dictionary if you didn't remember it. So I didn't really say it much. I maybe only said this word once. Does anyone know this word? Thrust? It's the force, but what type of force? No? Yeah, in other words, the force going up.
Yeah.
So what happens here now is the rocket gets turned on, and the engine gives it a force going up. Now I gave you the formula for this. Do you remember what it is? The force for the rocket when it's moving. Yeah, it's mv, but what was it before mv? The change in momentum over the time, yeah. So if I do this per second, then that means this here is equal to 1. So it's just equal to the change in momentum, which is mv minus mu. The u is 0 because the gas is at rest inside the rocket. Now in the question, how fast is the gas going? What do I say? 100 meters per second. That's how fast the gas is going. And per second, how much gas comes out? Can you see it in your question?
90 grams.
Not 90 grams. No, not this. Can you see it, Grace? How much gas per second?
90 grams per second.
I think maybe you wrote it down wrong. 90 grams?
Yeah, 90% of it. No.
9 kilograms is what I said. Isn't it?
Okay, no.
9 kilograms. So it is 9 kilograms per second at a speed of 100 meters per second. So the thrust is 100 newtons. Yeah?
Okay.
Are we okay with that? Yeah? Okay, good. Good, good. Now, part D is when the engine is on, what is the reaction force? So we have now a reaction force, and we have a thrust, and we have a weight. 981 newtons. So maybe someone can actually see straight away. What does the oar need to be to keep it balanced? 81.
But why did they say at t is equals to 0?
Yeah, in other words, the moment the engine turns on,
No.
there's not going to be any reaction force once the rocket leaves the pad, because the pad isn't touching the rocket anymore.
So what is the reaction at t is equals to 1?
That's equal to 0.
And t equals to 1?
Yeah. Yeah. Because there's no reaction when the rocket leaves the pad. Because the reaction, you need a contact, you know. Like for example here.
How much is meant to be 0?
The reaction.
Yeah, you said there's no reaction when it has not left the pad.
Correct.
And t is equals to 0.
Yeah. That is the exact moment the rocket has turned on, but the rocket has not taken off yet. Yeah, there's a bit of a delay. And that's actually part of the question. We'll see in the next part. Now, here's part E. Who can tell me this? Why does the rocket not take off in this picture? When t is 0 and the engine turns on, why is the rocket not moving? Why is it still sitting on the ground?
Because the upward force and the downward force are the same.
Yeah, the upwards equals the downwards. In fact, how much force is the engine providing? How much force from the engine?
900.
900. And what's the weight? 981. So will the rocket move? No. There's not enough force in the engine. So no. But of course the rocket will move, just not at the beginning. So we have to wait a few seconds before the rocket moves. Who can tell me why we need to wait a few seconds before the rocket takes off?
Then more kilogram of gas would have come out.
Yeah, and so what does that help?
Increase the...
No, the force is always going to be 900. So keep that in mind. Yes, the weight is decreasing. Why is the weight decreasing, Tacken? The gas is coming out. So how long do we have to wait? Until the 900 force is more than the weight. Yeah? So let's work out how long that will take. Okay? So if the force here is 900, then we want the weight to be 900. And weight equals mg. So that means we want the mass to be 900 over 9.81. So we want the mass to be 91.7 kilograms.
Why 900?
Because that's how much force the engine can provide.
Is it not meant to be less than that?
Well, when it's equal, that's the point where it can start to move. So, in other words, immediately after that moment, it can move. So how much mass is lost per second by the rocket? How much mass is lost per second by the rocket?
9 kilograms.
9 kilograms. Therefore, how long do we need to wait until the rocket can move?
Probably 1 second.
Just 1 second, because after 1 second, what's the mass? 91, which is less than this number. So the rocket can move after 1 second. So if you want to think about it like this, t less than 0, the engine is off. T equals 0, the engine is on, but we don't move. Don't move. And then once t is bigger than or equal 1, then we have liftoff. And you can see this when you watch rockets take off. You know, you see the engine come on, and then the rocket very slowly starts to move. It doesn't go straight away. Do you ever watch the video of a rocket moving? Yeah. So when the engine turns on, the rocket, it almost looks like it's not moving. And then it starts to move. We have to wait until it's lost some of its mass. Yeah? This is okay? Yeah? Right. How long will the fuel last? How much time do we have for fuel? Well, how much fuel do we have in total? 90 kilograms. And how much fuel do we use per second? 9 kilograms. So therefore, when are we out of fuel? After 10 seconds.
Wait, how come this,
Yeah?
the fuel is 90 kilograms?
Because in the question I said that 90% of the rocket's mass is fuel, and the rocket is 100 kilograms.
No, the rocket is just 10 kilograms.
The actual, it's only a small, it's only supposed to be a small rocket. Yeah, it's just 10 kilograms. Yeah. Okay, so it'll last for 10 seconds. Yeah? Okay. Can I do the last part now, which is the very difficult part? Is how high can the rocket go? Yeah? So, okay, can I scroll down? Yeah? Okay. So let's just draw a little picture of what's happening. So this here is t less than 0. And then here this is when t is between 0 and 1. And then as soon as t is past 1, but it's less than 10, it's taken off. And then at the very top here, when t is bigger than 10, there's no fuel left. So it still goes up, but there's no more fuel. So actually, let me put in colors here. So look, here the engine is off, here the engine is on, and here the engine is on, and now here the engine is off again. So what's going to happen is it's just going to go up and then splat.
The rocket.
What? What's wrong?
Oh, the astronaut inside.
No. It's only a 100 kilogram rocket. It's like a little toy rocket that people do, you know? It'd be very impressive if you could get a person in a 100 kilogram rocket, considering, you know, like, some people are more than 100 kilograms. Okay, so I want to know what is the maximum height here. So what I'll do is, first I'll try and work out the height, so first I want to work out this height here. Okay, so let's try and use Newton's law here, F equals ma, because we would like to know what the A is. And just to be very, very clear, I'm only looking firstly at this part in green, and then this part in blue is a separate problem. And what type of problem is this? It's a projectile problem, yeah, which is what you just did today. Okay. All right. So what's the F here? What's the F here? You have this one, and then you have this one. You have an F. Well, you have a force going up, and you have a force here going down, which is the weight. So how much force did I say was going up? No, not. How much force did I say was going up? The thrust? 900, wasn't it? So I have 900 minus what? Minus what? What's the force going down? Yeah, what's it called? The weight. Yeah? And what is the weight? Yeah, and what is it here? What number? 981. Is it?
Yeah. No.
Well, not really, because it's only 981 at the start. But what's happening as time is going on? The rate is getting reduced, isn't it?
Yeah, sure.
So I don't use 981. What could I use?
9.9.
Well, I could use the average weight. Okay, so look here. At the beginning, there is 100 kilograms of rocket, so that means there's 981 newtons. And then at the end, how much rocket is left? 10 kilograms. So what's the weight here? It'll be 9.81 newtons.
So the rate is getting in speed.
It's decreasing, so what we could do is just use the average weight.
This is 9.81 or 9.
So can you get the average here?
Sorry, thank you. It's 9.81 times 10. 98.1, thank you, yeah. 98.1. Yeah, what are you saying, Cora? We can get the average, isn't it? Yeah. So 981 plus 98.1 divided by 2. So on average, in the middle here, the weight is we'll just say 540 newtons. Okay, can I go back here? Sorry, what did I just say? 540. Now, once again, the mass, what do I use for the mass? Do I use 100? Do I use 10? Again, I have to use the average because the mass is changing. So, let's go back to our picture. It starts at 100 and it finishes at 10, so on average the mass is 55 kilograms. On average. Okay? So the acceleration is upwards 6.54 meters per second squared. Now, is that the exact answer? No, because we have to use an average. So, it's roughly this. But please don't think that this is exact. Okay, it's just, it's a very close answer to what's accurate, but it's only an approximation. That's the average mass of the rocket. It goes from 100 to 10 kilograms. Okay? Right, so now we have our UVATS. U is 0. What's V? We don't know actually how fast it's going when it reaches the top. What's A? 6.54. But I do know the T. What's the T? 10. Is this enough information to get the S? It sure is. S equals UT plus a half AT squared. Okay, a half AT squared. So I got here S equals 327 meters. I would also like to know what the V is. V equals U plus AT. So that would be 65.4 meters per second. So now it is now I have this number here, 327, that's this answer here. Now what I can do is do it as a projectile. What's the U for this problem? Who can tell me? What's the U for this part where it goes up and then splat? What's the U? Oh, you do? You do?
0?
No, it's not 0. It'll be 0 at the top here. Not here though. What is it? No, it's positive. It's flying up still. Well, it will be 65.4 because the U here will be the V from this part. The speed here is the final speed for this one. What's the V? Now the V is 0 because you want it to go to here. What's the A? minus 9.81. So now I can get the S. V squared equals U squared plus 2AS. 0 equals 65.4 squared minus 2AS. 65.4 squared minus 2A. Oh, sorry. So this here is 281 meters. So then the total is this number plus this number. So the rocket goes 545 meters in total. Now this question, I know it's difficult, but I have seen it in the exam.
This question.
Yep. So this is why I get worried when people don't do their revision, because I know it's difficult, but you need to revise it so that if you get it in an exam, you can do it. Like the projectiles today. So maybe this question could be on your mid-semester test. Because when I give you your mid-semester test after the holidays, I'll only use questions from the homework.
Only for homework? Why?
Because I'm trying to be nice.
Yeah, I know, but why you try to be nice?
Because you might not think it, but I'm a nice guy. Okay?
Also school, right?
Yeah. So this is why it's important to review these, okay? And yes, I have seen this in the exam twice. So you could get it in the final exam, I mean. Okay? So I'll leave this one and then we'll go on to the next one, which was your homework with the turning force. Okay? Can you take that out, please?